The first thing that I want to point out about teaching you how to do conversions is that there is more than one correct way to do this. So if you are comfortable doing your math a particular way, then do not feel like you need to adjust to my method. But if conversions has never been something that you are particularly strong at, hopefully this will make it more clear. And if you just need a reminder, then maybe this will help you remember what we did in Honors Chem. Two things. One, we're going to review metric switches, and on page 17, there's a metric staircase, and we're also going to do standard ones, but I'll get to that in a minute. First, I want to review the metric staircase. So, if you are given a question where you have to convert, the first thing you need to do is remember every single problem that we do in chemistry, you always start with the number that's in the question. So we're going to start with 0.098 liters. Okay, and then we are converting it. So I'm going to multiply by an empty fraction. So this fraction is what we call a conversion factor, and it's the difference between a milliliter and a liter. On the metric staircase, it's a difference of 3 steps, which means it's a difference of 10 to the third power, so there's 3 zeros. We're going to get rid of liter. So 1 liter, which is the base unit, is going to go at the bottom of this fraction because when we multiply these two numbers together, we want L to cancel out. And then milliliters, if you're going down the staircase, your number is going to get bigger, and you're going down this metric staircase 3 times. So essentially, we're multiplying by 1,000. Okay, when we multiply this number, which is really over 1, if you do 0.098 times 1,000 over 1 times 1, you end up with 98 milliliters because the liter cancels out. This was 2 significant figures when we started. It's still 2 when we're done, so that is the answer to the question. Similar thing, just a bigger number. Always start with the number that's in the question, 1.5 times 10 to the 6 centimeters. There is a difference of 5 steps between centimeter and kilometer. But this time we're going up the staircase, so we're going to be dividing by 1 with a whole bunch of zeros. So there's 5 steps, 10 to the 5th. We're going to put centimeter down here so that it cancels out. And we're going to say that there are 10 to the 5th centimeters in 1 kilometer. So the reason why these significant figures don't matter, just as a review of the last video, that is considered an exact number. So that's 1.0 to infinity, 10 to the 5th to infinity, like they do not affect sig figs. This number over here was a measured value that somebody put into this question. So those 2 digits are the ones that we're going to care about. And the answer to this question is just 1.5 kilometers because centimeters cancels out. All right, last one, 1.45 times 10 to the negative 5th millisecond. We're going to put milliseconds here because we know we want that to go away, and nanoseconds here. So milliseconds are larger. That means we're going down the staircase, so we're going to be multiplying by a number. And even though the staircase doesn't show all the steps in between, there is a difference of 6 zeros between a nanosecond and a millisecond. So really, we're multiplying by 100,000. And again, the sig figs in this step do not matter, but they do in this because the number in the question is assumed to be a measured value, and the numbers that are in the conversion factor are exact. So the answer to that question would be 14.5 nanoseconds. We had 3 sig figs here. We have 3 sig figs here. The next part of the review is with standard conversions, so like pounds to kilograms or quarts to liters or whatever. The first example, and that's on page, page 18 has a whole bunch of those on it. You don't have to have them memorized. If they're gonna be on a test, I'll just write them on the board, so don't worry about it. So same concept, except we don't have to deal with 10 to the whatever power. If we have 3.4 pounds, again, always starting with the number in the question, that's over an invisible 1. We're going to set up the conversion between kilograms and pounds, which the book says is 2.205 pounds for every 1 kilogram. Again, when we're multiplying the numerators and multiplying the denominators, we're going to have pounds over pounds, so that's going to cancel out. And basically all this is 3.4 divided by 2.205. Okay, remember the conversions are exact, So the 3.4, that's just two significant figures. So no matter what the calculator says, your answer should only have two numbers. And that's going to be 1.5 kilograms. Okay, so 5 kilometer race. Okay, even though kilometer is metric, there's a conversion between it and standard. So kilometer goes here, miles going to go there. The book says that there is 0.6, I'm going to run out of room, 214 miles for 1 kilometer. Okay, K is going to cancel out and miles will be left. Basically, this is just a multiplication problem. But important to remember, there's only one significant figure, so no matter what you get, you've got to round it to one number. So it's going to be 3 miles. Okay. On page 29, this is actually an example in the book. This is a combined standard conversion and metric conversion. We're starting with 1.76 yards. So for the most part, you're probably not going to find a conversion sheet that's got yards to centimeters, but we can go from yards to meters and then use the metric system to go from a base unit of meter to centimeter. So we're going to start with yards. And keeping with our sig figs, that is 1.61 meters. So now we have to do the second step where we go from meters to centimeters using the metric staircase. And this is where you'll see a difference between how the book does this and how I do this. I prefer to think going down the staircase as multiplying, going up the staircase as dividing. In the book, it has 1 centimeter over 10 to the negative 2 meters. And if you remember from math, multiplying by 10 to the 2 and dividing by 10 to the negative 2 are the same thing. So that's what I meant when I said there is more than one way to set these up where you're going to get the right answer. I just prefer to have a difference between going up and down the staircase. I think it's easier to remember, but whatever. It's up to you. So 1.61 times 100 is 161. We started with 3 sig figs. It is 3 sig figs now. Meters and yards have canceled out. So we have successfully converted between 2 units. This one's a little bit harder. So we have liters to inches cubed. The connection that you have to make here is inches can be related, well, inches cubed can be related to centimeters cubed, and centimeters cubed are the same as milliliters, which we can get from liters. So this is actually a 3-step question. We have to start by taking liter and making it into a smaller unit like milliliter, which we can then finally eventually get to inches cubed. So we're going down the staircase, which is multiplying 10 to the third milliliters for every 1 liter. And that means we have 5,700 liters. Milliliters. Whoops. 5,700 milliliters is the same thing as 5,700 centimeters cubed. So now we're just going to switch that unit. You don't really have to do a math step for that. Now this is what we have. Okay, so the issue here is that centimeters cubed and inches are not directly related, but a centimeter and an inch are. So if we set that up, there's 2.54 centimeters in 1 inch. Okay, but the problem is that this is a cubed. So what we need to do is we need to cube both of these numbers in order to account for that. So now centimeters cubed will be canceled out. So we're really dividing by a much bigger number than 2.54 because of that cube. And that leads us to an answer of 348 inches cubed if we round to adjust for the 3 sig figs that were in the original number. Last example. So we can use density as a conversion factor as well. It's grams per centimeter cubed or grams per milliliter. This question is asking you to convert a volume of jet fuel in liters to what would the mass of it be in kilograms. But the problem is that this is liters and the value for density that's given to you is in 2 different units, and then we're also going to have to switch it to kilograms when we're done. There was a question similar to this in the lab that we did, but maybe you got it, maybe you didn't. We'll see. So first thing is liters too big. We need to get something closer to centimeters cubed. So I'm going to go down the staircase. Okay, multiply by 10 to the third milliliters, get rid of liter. This leaves us with a humongous number of milliliters, which is fine. And easy conversion. We don't really have to do anything because milliliters and centimeters cubed, are the same thing. So we really have 173,231,000 centimeters cubed. And now we need to set up the next step to convert to mass. So we have our volume, we need to use density to convert to the next unit so that we can eventually figure out kilograms. And this can be easily done by setting up density like it's a conversion unit. So instead of writing it this way, if you use it like a fraction, the centimeters cubed are going to cancel out and we end up with grams. The mass that we get in grams is still very, very large, so we're going to go that last step to convert to a larger unit, which still gives us a huge answer, but whatever. And we're going to convert to kilograms by going up the staircase 3 steps. So that is going to change our answer to 133,041 kilograms. Okay, here's the issue. This time we had 2 numbers that were measured. So we're going to go ahead and assume that density is not exact because that's always a measured value. That's 3 significant figures. The volume was 6 significant figures. So we need to round all this down to 3 sig figs because this is all multiplication. So it's 133,000 kilograms, or as the book has written, 1.33 times 10 to the 5, which is the same thing.